Okay, now that we've learned all about significance testing, let's go a little bit further and talk about the types of errors that we can commit when performing hypothesis testing. In statistical hypothesis testing, we're never really 100% certain, and that's because we rely on probabilities to experiments. So even though reliable, hypothesis testing can sometimes fall into errors known as type 1 and type 2 errors. So type 1 error is rejecting the null hypothesis when it's actually true, and type 2 error is not rejecting the null hypothesis when it's actually false. So let's look at type 1 error first, which is often known as false positive. This happens in hypothesis testing when the null hypothesis is true, but is rejected. Or more simply, when the tester validates a statistically significant difference even though there isn't any. Type 1 error have a probability of alpha, which is correlated to the level of confidence that you set, and is represented also as the p-value, which you can use to reject or accept the null hypothesis. So for example, a confidence of 0.05 means that there is a 5% chance that you are wrong when you're rejecting the null hypothesis. Alternatively, making a false negative is referred to as a type 2 error. And this happens when we conclude that there is not a significant effect when there actually is. And the probability of making a type 2 error is called beta, and this relates to the power of the statistical test, in which power is 1 minus beta. And we'll learn more about this more in depth in our next session, which will talk about statistical power, where we'll learn that we can decrease our risk of committing a type 2 error by making sure our tests have enough power. And similar to type 1, type 2 error can lead to the false assumptions of your test and also just poor decision making. So now let's look at this figure to see if we can summarize all we just said and have a better intuition. The top here is our truths, that we're saying that the truth is either the null hypothesis is true or the truth is that the null hypothesis is false. And then we can conclude from our analysis that we either accept the null hypothesis or we reject the null hypothesis. So let's look at this top left corner. If we accept the null hypothesis and the truth is that the null hypothesis is true, then we have correctly accepted the null hypothesis. However, if we accept the null hypothesis and the truth is that it is false, we are committing a type 2 error, and now we've introduced a false negative. Likewise, if we reject the null hypothesis and it's true, we're committing a type 1 error, introducing a false positive. And if we reject the null hypothesis and the truth is that it is false, then we have correctly rejected the null hypothesis. Now remember that these are just probabilities, right? So when you design an experiment, you want to have a high chance of not making these types of errors. And what I just said there is, again, the concept of statistical power, and we'll go over that in the next session. But since we're on the topic, we can just lay down some groundwork and provide some labels for these type of errors. So alpha here will represent the probability of making a type 1 error, and beta will be the probability of making a type 2 error. And we can think of this as confidence is the complement of alpha, and power is the complement of beta. Thus, confidence is 1 minus alpha, and power is 1 minus beta. So that's it for this video. In the next video, we'll jump into what is power and how we can utilize it to figure out things like, well, we just accepted our null hypothesis, but was that study powerful enough to avoid these type of errors? Thank you.